Hey y'all, welcome back. On tonight's homework, we are factoring quadratic trinomials, specifically when the leading coefficient is not 1. These are a little trickier to handle than the trinomials where a is 1, but hopefully I can break it down for you so that after we do a few of these, you'll really get the hang of how to correctly factor them. The good news is on the TSI A2, there won't be a ton of these kind of problems. There will be sort of a mix of factoring from what I understand, where there's some GCF factoring, some factoring where the leading coefficient is 1, and then you might get one, maybe two problems max where the leading coefficient isn't 1. But it would be nice if you could get these right. So the way to handle these quadratic trinomials where the a value is 1 is to use a combination of the big X that we used in the previous lesson and the area model. So let's start by using the big X. And when we start this big X, we're going to approach it just slightly differently than we did before. We need to find two numbers that multiply to the product of 2 and negative 12. So that would be negative 24, and add up to the number in the middle, which is 5. And what we're going to do, these two numbers are not going to just basically give us the answer like they did when the leading coefficient was 1, but what they will do is help us fill in this area model with the two linear terms that we will write in the bottom left box and the top right box. In the top left, that will be just whatever the leading term is. So I'll just lock that in as 2x squared. And then the constant term, negative 12, goes here in the bottom. So after you come up with your big X, you want to come up with two numbers that multiply to give me negative 24 and add up to 5. Our factors of 24 are 1 and 24, 2 and 12, 3 and 8, and 4 and 6. And since the product here is negative, one of the numbers has to be negative. And if we're looking for a combination that adds up to 5, but one of the numbers is negative, the only one that really works there is 8 and 3. 8 plus negative 3 is 5. So I'm going to write that here. Negative 3 and positive 8. If you multiply those two together, you get negative 24. You add them, you get 5. And those numbers are going to be the coefficients of the linear terms that we put into those two highlighted boxes. Doesn't really matter which one you put where as far as those two boxes are concerned. You could put the negative 3x here and the 8x here, or swap them. It's not really going to affect how we work this problem or whether or not we get the right answer. Now, to come up with the factors, once you've got this set up, ready to go, you want to find the greatest common factor of each column and each row and write that above or to the left of those columns and rows. So if I look at this first column, the GCF between 2 and 3, those are both prime. They don't have a common factor, but both of these terms have an X. So the GCF of that column is X. The GCF of the second column, right here, is going to be 4. Both of these are divisible by 4, but they both don't have an X, so we can't pull out an X as well. So one of the factors is going to be X plus 4. The other factor we'll get from factoring the GCF of the two columns. So the GCF of the first column would be 2x, and the GCF of the second column would be negative 3. So the two factors here are going to be x plus 4 and 2x minus 3. So for number 1, looks like our answer is D. For number 2, and really for the rest of these, we're going to work them out exactly the same way. So maybe I'll actually leave number 1 up here so you can kind of see the structure of how we came up with the factors. So we are going to start with an X method, a big X. 2 times 21 is 42. So we're looking for two numbers that multiply to give me 42 and add up to 17. Those two numbers, those two special numbers, are going to go in the bottom left and the top right boxes in this area model. The leading term, 2x squared, should go in the top left, and the constant term 21 should go in the bottom right. So now let's come up with some factors of 42. Since both of these numbers are positive, I don't need to worry about one of them being negative or anything. We're just going to start listing out some factors, and hopefully we can find a factor pair that adds up to 17. So we have 1 times 42. That doesn't work. 2 times 21. That would add up to 23, but we're getting closer. 3 times, what would that be? 14, and I think that's going to be our winner. Is there anything else here? Just kind of cover yeah, we can do 6 and 7. My students are going to like that one, but that's not going to be the right combination. It's going to be 3 and 14. So 3 and 14 are going to be our special two numbers here. So we've got 3 and 14. Those are going to be the coefficients of the two linear terms that we put in our area model, 3x and 14x. Again, which one goes where as far as those two boxes are concerned doesn't really matter. I'm going to just move this over a little bit, although it didn't really grab everything I wanted to. So let's fix that. Now it's not going to let me grab that separately. I don't know. It's kind of weird. Okay, now we got that all fixed up. So now let's find the GCF, or the greatest common factor, of each column and each row. I'll start with the columns. The first greatest common factor of this first column is going to be x. In the second column will be 7. So one of the factors is x plus 7. That kind of narrows it down a little bit. We've got 3 answer choices with x plus 7. But now let's find the GCF of each row. For the first row, the GCF is 2x. And for the second row, the GCF is 3. So the first factor was x plus 7. The second factor is 2x plus 3. So our answer is A. For number 3, we'll approach this the same way. And really, again, we'll work all these problems basically the same way. Okay, so I'm going to set up my x. I'm going to set up my box, or my area model. I'm going to write 5 times negative, I might have to do a little scratch work here, or you could just use your calculator. But 5 times negative 18 is negative 90, and the middle term is negative 1. So that means the two factors have got to be right next to each other. In other words, they have got to have a difference of 1. So two numbers that multiply to give me 90 add up to negative 1. When I'm thinking of my factor pairs of 90, I've got 1 and 90, and you should know right away that's not going to work. We need one of these numbers to be negative so that the product is negative, and we also need the difference to be 1. So the two numbers need to be basically just one number away from each other, like a 6 and 7 or something like that. So if we keep going, we got 2 times 45. No, obviously that's not going to work. 3 and 30, of course not. 90 is not, or is it divisible by 4? I don't think it is, but it is divisible by 5. 5 times 18. We're getting closer. Notice these numbers are getting closer together. So let's just keep going. And you can use your calculator if you're not sure if it's a factor. I'm just checking in the calculator right now. 90 divided by 6 is 15, so 6 and 15 will work. Yeah, pretty sure it's not divisible by 7 or 8. But 9 surely works. 9 times 10. And look, those are 1 off from each other. So in order for them to add up to negative 1, the 10 is going to have to be the negative number. So we've got negative 10 and positive 9. When I go to set up my area model, the leading term, 5x squared, goes in the top left. Negative 18 goes in the bottom right. And then negative 10 and 9 are going to be the linear coefficients of these other two boxes. So negative 10x and 9x. So now let's look for our greatest common factors of each row and each column. In the first column, the GCF is going to be 5x. In the second column, it'll just be 9. So we get 5x plus 9 is one of the factors. And then if we find the GCF of each row, on the first row, the GCF is x. And in the second row would be negative 2. So the two factors should be 5x plus 9 times x minus 2. I'm going to just fix that x there. It's a pretty ugly x. That's not much better. What's going on here? Oh, there we go. So yeah, 5x plus 9, x minus 2. Our answer is D. Number 4. Let's get our big X set up, get our box set up. The number that we're trying to multiply to is going to be 6. Number we're trying to add to is 7. This one might be a little easier because the numbers are smaller. In my area model, the top left is going to be 2x squared, and the bottom right will be 3. So now we're ready to find those two numbers. And really, the only two numbers that'll work here will be 6 and 1. So we've got 6x and 1x, and now let's find our GCFs. The GCF of the first column would be 2x. Notice there's not really a common factor between x and 3, but if that happens, everything has a common factor of 1, so our GCF here is just 1. Looking at the rows, the first row has a GCF of x, and the second row has a GCF of 3. So the second factor would be x plus 3. Our two factors are 2x plus 1 and x plus 3. So our answer is, let's see here, it is C. Number 5. And keep that previous problem up so you can just see the similarity in the structure of how we work in these. Here we're going to want to factor out the GCF up front to make this factoring a little easier. We really should have been looking for that all along. But here, if we factor out a 2 as a GCF, that leaves me with x squared plus 3x minus 4. And now actually we have an easier problem to factor. We can go back to the classic big X, where we don't have to set up an area model unless we want to check our answer. But here we need two numbers that multiply to give me -4 and add up to 3. Those two numbers would be 4 and -1. So the other two factors, other than the 2, would be x plus 4 and x minus 1. So you want to be careful here. This problem is a lot easier if you factor out that GCF up front. And so, yeah, our answer is B. Number 6 says x minus 1 is a factor of which of the following? So we're going to need to factor both of these, but that's okay. So let's start with factoring part, the first one. If we have x squared plus x minus 2, the leading coefficient is 1, so we can just do classic big X here. Two numbers that multiply to give me -2 and add up to 1 would be 2 and -1. So that gives you the factors right away, x plus 2 and x minus 1. Now, it says x minus 1 is a factor of which of the following. This guarantees that, yeah, the first one is going to be 1. But now let's check the second one. This is going to be the more advanced one where we have a leading coefficient that's not 1. So here we'll have to use the big X and the area model to factor. Here we're trying to find two numbers that multiply to give me 6, which is the product of 2 and 3, and add up to -5, which is that linear coefficient. We will lock in the first term, which is 2x squared in the top left box, and the constant 3 in the bottom right box. So using that big X, we need two numbers that multiply to give me 6, but add up to -5, and those two numbers would be -2 and -3. So the two terms to put in these two boxes right here would be -2x and -3x. Now let's find the GCF out of each column and each row. For the first column, our GCF is 2x. In the second column, the GCF would be -3. So one of the factors is 2x minus 3. And then going down the rows, we have x and just -1. So our two factors here are 2x minus 3 and x minus 1. Notice that x minus 1 is a factor of both. So not only is it a factor of the first one, it's a factor of the second one also. So the answer is going to be C. All right, so here we've just got some mixed factoring practice, no multiple choice or anything, but we just want to be comfortable with any of these trinomials they're going to throw at us. On the TSI A2, they're not going to be separated as far as like what style of quadratic that you're supposed to factor. So you just have to be ready to do either one. And as we go through these, I'm going to point out like which ones are going to be the easier ones and which one will be the more difficult ones. So with number 7, the leading coefficient is 1, so we can just do a basic x here with 18 on top, negative 11 on the bottom. Two numbers that multiply to give me 18 but add up to negative 11 would be negative 9 and negative 2. So the two factors will be x minus 9 and x minus 2. Number 8 can be worked similarly. The leading coefficient is 1 again, so we can just use a basic x here. Two numbers that multiply to give me 30 and add up to 13 would be 10 and 3. So the two factors will be x plus 10 and x plus 3. Both 7 and 8 kind of fall into the easy category. Anytime that leading coefficient is 1, you can work it out really just like this. The only thing that might give you some trouble is coming up with those two numbers. So like on number 8, for instance, you might consider writing out all the factor pairs that you can think of and just kind of wait until you see one that adds up to 13, and you'll eventually get there. Number 9 looks like it's going to be a hard one until you realize that 3 is a GCF. So let's factor out that leading coefficient 3, be left with t squared plus 3t plus 2, and now we can factor what's remaining in those parentheses like a quadratic that has a leading coefficient of 1. So I'm going to do a big X here with 2 and 3, and two numbers that multiply to give me 2 but add up to 3 would be 2 and 1. 2 is prime, so hopefully that one didn't take you too long to figure out. And so we still have that factor of 3 that we factored out as a GCF, but the other two factors will be t plus 2 and t plus 1. So just be on the lookout. It might look like it's going to be an A not 1 trinomial, but if you can factor out a GCF and make that a little bit easier, definitely want to do that. Number 10, this one also has a GCF that we can factor out. All three of those numbers are divisible by 4. So I can factor out a 4, leaving me with x squared plus 3x plus 2. This is actually going to be factored exactly the same way as the last one, right, with 2 and 3. So two numbers that multiply to give me 2 and add up to 3, again, are going to be 2 and 1. And so our factors are 4, x plus 2, and x plus 1. Number 11 is really the only one in this little batch of problems here where the leading coefficient's not 1, and we can't factor out a GCF, so we're just going to have to kind of go with it. Now, one thing you can do to make this a little bit easier is to actually factor out a negative 1 to make that leading coefficient positive. You don't have to do this, but I just find the factoring to go a little bit easier if that leading coefficient is positive. So either way, we're going to need an x and we're going to need an area model. So the number on top, now that I've taken out that negative 1, would be 2 times 6, which is 12. And the number on the bottom, what we're trying to add to, would be negative 7. Both numbers are going to have to be negative here if they add up to a negative but multiply to a positive. And the two numbers that'll work here are going to be negative 3 and negative 4. So now we're ready to start our area model. The leading term, 2y squared, will go in the top left. 6 will go in the bottom right. And then those two special numbers we just found, negative 3 and negative 4, will be the coefficients of the two linear terms in these two last boxes. So now we're ready to find the GCF of each row and each column. For that first column, 2y squared and negative 3y, the GCF is just y. 2 and 3 don't have any common factors other than 1. In that second column, we're going to factor out a negative 2. Now let's go down on the rows. So in that first row, we've got 2y as our GCF. And in the second row, we've got negative 3. So these are the last two factors, meaning in factored form, I've got that negative 1 that I pulled out originally, then y minus 2 times 2y minus 3. If you didn't factor that out, you can still work this one out. You'll just have one of these two factors will have flipped signs. So maybe you'll have like a negative y plus 2 or maybe a negative 2y plus 3, either one, not both, but one of them for sure. Number 12, notice that there's no b term here. The linear coefficient is 0. This is a difference of two squares, and anything that's in the form a squared minus b squared, or this difference of two squares, can be factored as a plus b times a minus b. So while you can treat this like, do the big X and put 0 on the bottom, it's still workable like that. However, it's probably easier to just remember this difference of two squares rule and just recognize it when you see it, so that we can rewrite this as x plus 6 and x minus 6, because x is the square root of x squared and 6 is the square root of 36. Okay, that takes us to the last page here. We're doing a little geometry applications. It says the area of a rectangle is 6x squared plus 13x plus 6. What are the dimensions of the rectangle? So we've got this rectangle, and really you just want to kind of think about it using that area model. Okay, we'll put 6x squared on top and 6 in the bottom right. We'll use the big X to figure out what those other two numbers are, with 6 times 6 being 36 on top and 13 on the bottom. So we need to find factor pairs that multiply to give me 36 and add up to 13. Our factor pairs of 36 are 1 times 36, 2 times 18, 3 times 12, 4 times 9. This kind of has a lot, but and then 6 times 6. And so if we're trying to add up to 13, we're going to use 4, 9. So yeah, we've got 4 and 9 as our two special numbers there. So I'm going to put 4x and 9x into these two other boxes. Now I'll factor out the GCF out of each column and each row. So in that first column, my GCF is 2x. In the second column, the GCF is 3. So that's going to be one of the dimensions, 2x plus 3. And then the other dimension is going to be 3x plus 2. So yeah, so this expression, this 6x squared plus 13x plus 6 equals 2x plus 3 times 3x plus 2. Since the area of a rectangle is base times height, I think it's safe to assume one of these is the base, one of them is the height, but either way, those are the two dimensions. The next part says, what's the perimeter in terms of x? Well, if we have a rectangle, and we already found what the dimensions are, right? We know that the top is 2x plus 3, and the side is 3x plus 2. A rectangle has congruent sides that are opposite of each other, which means this other side over here is 3x plus 2, and then the bottom side's also 2x plus 3. Perimeter means we want to add up all of the sides. So we just need to add up all 4 of these sides. So we have 2x plus 3 plus another 2x plus 3 plus a 3x plus 2 plus another 3x plus 2. And we just need to add all these up. 3 and 3 is 6, plus 2 is 8, plus 2 is 10. And then if we're looking at all our linear terms, we can add those together. 2 and 2 are 4. 4 and 3 is 7. Plus 3 is another 10. So yeah, 10x plus 10. So that is going to be our perimeter. Part C says, what is the perimeter if x equals 3? Well, if we know that the perimeter is 10x plus 10, then if x equals 3, we have 10 times 3 plus 10. So 10 plus 3 is 30. Sorry, did I say 10 plus 3? I meant 10 times 3 is 30, plus 10 is 40. And last question of the homework, what is the area if x equals 3? Well, you could either use the factored form, which might be easier, or you can use the original expression. And this might be a good way to check and make sure we did it right. The original expression was 6x squared. Let me go see what the other part it was. 13x plus 6. I think. Yeah. And then our factored form was 3x plus 2 times 2x plus 3. So you really don't need to do both of them, but I just want to check and make sure we did it right. So I'm going to plug in 3 into both. If I get the same answer on both of these, then I know I did it right. So 6 times 3 squared plus 13 times 3 plus 6. Go ahead and use a calculator here. You don't need to do that by hand. 6 times 3 squared plus 13 times 3 plus 6, I'm just typing it in, is 99. And if I try that over here, where I have 3 times 3 plus 2 times 2 times 3 plus 3, I'm plugging in x equals 3, by the way. I get, let's see here, 9 plus 2 is 11. 2 times 3 is 6, plus 3 is 9. So I get 11 times 9, which, look at that, is also 99. So 99 is my area. And that is going to wrap it up for tonight's homework. I know that these problems are challenging, so just don't give up. Keep practicing, and you will be able to solve any of these factoring problems once you get the hang of it. If you have any questions, please reach out, and I'll be happy to help you. Other than that, thanks for watching, and y'all have a great day.